Hi, everybody. Welcome back to Dave's Math channel. I'm your host, David Tear, and this is my continuing feature on the Math Lovers book. And I guess I can give a little plug for my series again. I wrote this from 2019 to 2022. It's a 3-volume series called the Math Lovers book. And these are pictures of all the paperback versions. There's 3 of them, and the first one is the one I'm going through now. I'm up to chapter 6. This is more recreational math topics, and I'd say this one's a little more fun and it's a little less advanced. I'd say it's probably advanced high school level. It covers a lot of kind of fun topics like numbers, different kind of number systems, and sets and groups, which is I'm talking about now. I'm going to get to computation and logic and chaos and fractals, which are also pretty fun. Volume 2 is, I'd say, a little more academic. This one has stuff you probably learn in college, maybe advanced high school, like functions, functional analysis, and also calculus, differentiation, integration, and finally, at the end, I talk about probability and statistics. And then at the very end, I have a section on biographies of 80 famous mathematicians throughout history, listed chronologically. And I do that every Saturday. I have a feature on this channel where every Saturday I feature another biography of another famous mathematician throughout history. Done 20 out of 80 already. The last one I did was Blaise Pascal, very famous French mathematician. And then finally, the third volume, the yellow one on the right, is problems and solutions. And these are just problems pertaining to the first 2 volumes. And then I have solutions to all the odd number problems. I leave out the even number ones because I like you to do those yourself, and sort of self-correct them in life. There's no answer book. So anyway, that's just an overview of my Math Lovers book series, and you can buy either paperback or Kindle on Amazon. I forget the price, but I think they're pretty reasonable, and especially for Kindle. And if you don't want to pay for it, you can just keep watching this channel because I'm going to go over the whole first 2 volumes eventually. So anyway, that's the plug for my book. And today, like I said, we're still on group theory. I've been talking, I just a couple days ago started talking about infinite groups. And one class of infinite groups that are very important are groups known as Frieze groups. So anyway, let's begin. So what is a Frieze group? Well, they say a picture's worth 1,000 words, and maybe I'll just cut to the chase and show you a picture. This is probably the simplest Frieze group there is. It turns out there's 7 of them altogether, and they're basically sort of like one-dimensional wallpaper patterns. I'm going to talk about wallpaper groups next, which is basically all the different types of patterns that are possible to make with wallpaper, where it repeats, where it has a group structure. Turns out there's exactly 17 wallpaper groups, but there's just 7 Frieze groups. Anyway, and they all have what's called an IUC symbols for their notation. Set of numbers and letters. You don't have to worry about what these mean, but they're given names. The names I show here: P1, P11G, P1M1, P2, P2MG, P11M, and P2MM. Those are the names, the kind of international IUC names given for all the 7 Frieze group. There's also similar names for the wallpaper groups, and then there's a 3-dimensional analog of wallpaper groups called crystallographic groups. It turns out there's 230 of them. So anyway, I'll get to that, in maybe a couple of weeks. But anyway, let's just continue with Frieze groups. So the first example of a Frieze group, probably the simplest one, is this one we call P1. And there's sort of 2 ways you can think about Frieze groups. You can think about them as a one-dimensional pattern. And a lot of times you see these, like you'll see them on the ceiling of fancy houses or apartment complexes. You see these really elaborate patterns sometimes on the ceiling. And those are all examples of Frieze groups. So the simplest type of Frieze group just has one generator, and that one generator is a translation. And there's two ways, like I said, there's two ways you can think about a Frieze group. You can either think of it as a pattern that you might see on the ceiling, or you can think of it as a set of steps that you might take. And in this case, the step that corresponds to the P1 is a hop. So imagine you're hopping on the beach. Imagine you're just hopping on your left foot. And the left footprints are shown in red here, kind of like Jimi Hendrix said, footprints dressed in red. So you just imagine, you're hopping along the beach on your left foot, and this might be the pattern you see in the sand after you do that. You're just hopping a fixed distance with each hop. That's your translation. And that corresponds to this Frieze pattern where you got a straight, all these Frieze patterns are going to show a horizontal line in the middle, but here we have sort of the decoration on the side. In this case, that's going to be these hatch marks that go up and to the left. So I think you can see that this has the same kind of symmetry as the hop, just one translation. If you translate by a certain distance to the right, it looks the same. But that's the only thing you can do. So anyway, that's the simplest Frieze pattern. And what we have after that, P11G. G stands for glide reflection. This one's more complicated. But this is the Frieze pattern. I think maybe it's easier to start with the steps here. So imagine just walking on the beach. It's a lot easier than hopping on one foot. You just take your left foot and then you move your right foot in front of your left foot and then your left foot in front of your right foot, and this is the pattern you'll see on the sand of your footprints. Like I said, the left footprints are shown in red, the right footprints here are shown in blue. And now there's actually two different types of symmetries of this pattern. You have the translation you had before. That's when you go from, when you take two steps, you have a translational symmetry. But you also have what's called a glide reflection. And this is something I haven't talked about yet, in this book at least. I think I do have another video on symmetry where I talk about glide reflections. But what a glide reflection is, it's a reflection combined with a translation. So you'll notice, for instance, that your right foot looks like the mirror image of your left foot. But it's not just the mirror image in this case because we're also moving our right foot forward. So you'll notice that the right footprints aren't in line with the left footprints. So that's why the right footprint is not a pure reflection of the left footprint. You can't just put a mirror and get the right footprint from the left footprint. You have to actually move it forward as well. That's called a glide reflection. So this particular symmetry involves a glide reflection. And actually it turns out that a single glide reflection generates this group P11G. But it is a different group from P1. So that's the second of these 7 Frieze patterns. And what's next? This one looks a little simpler than the glide reflection. I kind of think it is. This is what's called a cycle. The name of this group is P1M1. And this one, there's two symmetries again. There's translational symmetry like there always are. All of these groups have a translational symmetry. That's kind of a requirement. You'll notice that. So in this thing, what the guy on the beach is doing, he's doing what's called a cycle. So this time he's standing, perpendicular to the way he was standing before. He's standing perpendicular to this line. What that means, the line is the direction of motion, which is horizontal. So in all these examples I'm going over, the guy is moving horizontally, but he's facing vertically. He's facing north, say, and he's moving east. So how can he move east if he's facing north? Well, he can jump sideways. That's what a cycle is. It's a sideways jump. So he's standing, facing forward. He jumps about 3 feet to the right, and then he ends up with a second set of footprints, and then he does it again, and he keeps doing that. That's called a cycle. And you'll notice the Frieze pattern above it. It has a translational symmetry to the right, but it also has a mirror symmetry about each of these hatch marks, just like there's a mirror symmetry between the left foot and the right foot. This time, this is a pure mirror symmetry. It's not a glide reflection. It's an ordinary reflection. So this one has an ordinary reflection and a translation. 2 generators, if you like. Anyway, that's the third example. And then we have a thing called P2. This is the step that involved in this is a very complicated step. It's called a spinning hop. And I wouldn't even want to try this. I'd probably fall on my face if I did. But again, you're hopping. Notice there's no blue footprint here, just a red footprint. But what you're doing is you're standing on one foot, and then you hop, and while you're hop, you spin 180 degrees around. So you land facing the opposite direction. Like I said, I would never try this because I'd probably fall on my face if I did. I'm not an acrobat. I'm not a natural acrobat. Maybe some of you guys are, but I'm not. But you can imagine someone in good shape doing this, and they'd be able to do this. And anyway, that's the steps he would take. So first, he standing on the left foot, he spins around and hops, but then he does it again. And now, these are glide reflections again. That's the other thing I should have pointed out. So not only is he spinning around, but he's moving forward each time he does so. That's why he lands ahead of where he was two hops ago. And then he keeps doing that. So the generator for this group is a glide reflection. And two glide reflections result in a translation to the right. So, and then the corresponding Frieze group would be this particular hatch pattern. This time, it's a little like it was for P1, except for P1, they were just on one side of the line. This time, they're on both sides of the line. So it has an additional symmetry. It has a twofold symmetry, meaning if if you look at where these hatch line segments intersect the horizontal line, that's the axis of twofold symmetry. If you rotated 180 degrees about these points, you would get back the pattern. Similarly, if you took a point in the middle of the spinning hop steps, you could rotate 180 degrees about that point, and it would look like it did again. So anyway, that's P2. What else can we get? We can do a spinning sidle. Yeah, I don't think this one's quite as bad as the spinning hop. I might be able to do this without falling on my face, but it's still pretty complicated. Here, what you have to do is you're standing with both of your feet aligned like you would ordinarily, but now you jump and you spin while you're jumping, and that's kind of hard to do. You're spinning 180 degrees again, but this time you're doing it and you're landing on both feet instead of on just one foot, and you keep doing that. You keep jumping and spinning, and each time you do, you're facing the opposite direction. And after you do it twice, you're back facing the same way you were, but you're translated to the right of where you started. And a corresponding Frieze pattern is the one shown here. You got the horizontal line, but now it looks like you have kind of like a triangular wave on top of that. So anyway, that would be the symmetry corresponding, and the group is called P2MG. Anyway, that's the fifth one. And then what else do we have? This one's pretty easy. I think anybody pretty much can do this one. This is just a jump. This group is called P11M. And, I guess it's a little like P1, but P1 we were hopping. P2 actually has another symmetry because it has the mirror symmetry of your left and right feet. You're using both feet, and your right foot is a mirror image of your left foot. So not only do you have a translational symmetry for this one, but you also have a reflection symmetry, a mirror symmetry about the horizontal axis. The Frieze pattern corresponding to this is shown above. Looks like a zipper, kind of. You got these hash marks that are mirror images of each other on either side of the horizontal line. Anyway, so now there's just one more translational symmetry. Again, this is a complicated one. A spinning jump. So we have the spinning sidle, remember, a couple ago. It's almost like the spinning cycle. You're jumping and spinning. But the difference here is that you are facing the line. You are facing vertically, if you like. You are facing north and moving east. And this one, you're facing north and moving north. So you're moving in the direction you're facing, but you're spinning every time you jump. Actually, I think this one's pretty hard to do because I guess the first time you jump, you move forward after you spin, but the second time you jump, you move backward. So the two jumps aren't equivalent. First time you're moving forward, second time you're moving backward. So by the time you've done 2 jumps, you've moved ahead 2 steps, and corresponding freeze pattern for that. It looks like this. Did I even get this right? I don't even think I did this right. I don't think I did. Yeah. Um, yeah. So anyway, yeah. So that's the last one. The freeze pattern for this looks pretty simple. It's just notice that there's a lot of symmetries in this one. You've got symmetry. You've got translational symmetry in the horizontal direction, like you always have, but you also have mirror symmetry. You have a lot of mirror symmetries here. You have mirror symmetry about the horizontal axis because your left and right feet are mirror images of each other. But you also have vertical mirror symmetry, which I don't think we had for the other ones. That's so you notice that if you reflected this whole figure about the horizontal line, it still looks the same, and that's not true in most of these other patterns. So anyway, those are the 7 Frieze groups, and that completes my video for today. Thank you for watching. Long live math, and I'll see you guys next time. Bye.